Welcome to a new episode in the Multiverse video series. I'm Javier Luraski, and today we're going to learn how to do D-tree visualizations using R. So what is D-tree? Well, D-tree is a JavaScript library. It has been popular for many years, and it allows you to create interactive visualizations that are easily available on websites and any web application. So for instance, let's just pick a couple visualizations from the D-tree gallery. So in this case, this is a visualization that allows you to easily filter across different plots. But we can pick other a little bit less conventional visualizations as well. This is a chord diagram. And as you can see, one characteristic usually of D-tree visualizations is that they're vectorized, which means that they're created using vector graphics, even though you don't necessarily have to use vector graphics. But it's a common practice when working with D-tree graphics, which allows them to be basically multi-resolution and high quality. Let's just look at a couple other ones. For instance, this looks like a scatter plot. This is a New York Times post, which I'm sure whoever was the person that created this diagram is likely that they spent quite a good amount of time just making sure that it is interactive with its performance and is interactive. So yeah, so as you can see, it's pretty great. It's pretty responsive, and in this video we're basically going to learn what exactly are D-tree visualizations and how you can make use of them inside R using the R2D3 package. All right, so these were a few cool examples. Let's just talk a little bit about what exactly is a D-tree document and what is the D-tree library itself. So for that, we're going to take a look at the Wikipedia page. So D-tree stands for data-driven documents. As it mentions in the JavaScript, in the Wikipedia page, is a JavaScript library. So it's basically just JavaScript code. D-tree is just that JavaScript code. And it says a library for producing dynamic, interactive data visualizations, which we mentioned. And it usually uses SVGs, which is scalar vector graphics, which again are pretty common when working with D-tree. You can also use CSS, which we'll look into. And so you can basically combine SVGs and CSS and style your visualizations in a similar way in which you style a web page. And it's also a framework, right? That allows you to build applications. So one of the things, we're not going to get into too many details, perhaps, but this is the magic behind D-tree. So if you look at what selections are, basically a selection is just a group of HTML elements. Now, you can use D-tree to build any sort of interactive application. It doesn't need to be a visualization application. You can create, say, a form or a table using D-tree. However, that's usually not the case, right? Like D-tree is usually mainly applied to visualizations. But in this example, as you can see here, they're actually using D-tree to select a P element, which is a paragraph. And kind of like the magic of D-tree comes from being able to operate over a large number of HTML elements. So rather than creating a for loop over all the P elements and change each element's style sheet one at a time, you can basically select them all and then apply style sheet over each of them. In this case, we're changing the color, and we're also applying a class and changing the position. So this is a very basic example, but things can get more complicated. In fact, one of the other great characteristics of D-tree is that you can combine them with CSS transitions. A CSS transition basically is an animation that the web browser provides for you. So in this case, we're selecting the P elements, and we're setting some duration for a transition, and we're changing the color. So rather than just changing the color automatically, the rendering engine behind a web browser will gonna animate this particular transition. And last but not least, the other great quality on on D-tree is that you can bind the HTML elements to a data set. So in this case, we have a very small data set. It's describing apparently a few countries. And what you can do is you can basically, again, select one of the elements, create an SVG element, yada, yada, yada. But then eventually what you can do is you can bind the elements to the data, right? So basically D-tree will try to create a one-to-one correspondence between your elements that you have selected in D-tree and the actual entries on your data set. And what is interesting is that you can specify to D-tree what is the behavior that you want to do whenever an element enters or exits your data set. So rather than having to specify, like, figuring out what are the new elements and where they go on your visualization and so on, you can basically let D-tree, you can specify in D-tree what is the behavior that should happen for the new elements that are entering, the elements that are exiting, and the elements that are getting updated, which again allows you to be more descriptive with less code while you're building your visualizations. All right, so let's take a look at a specific visualization and build from there. This is the D-tree gallery. There have a bunch of examples. There's a bubble chart, the core diagram that we look at. You can look at all of them and pick one that is interesting to you. So for instance, in this case, we can start with something easy, which is a bar chart. So let's take a look at this bar chart. Take a look at this one. Let's see. All right, so this is a bar chart. It has an axis and it has a little bit of interactivity. One of the things that you can see here is it has a bar, but also when you hover over it, it changes the color and you can see the frequency on the top. So if you wanted to use this particular code, D-tree visualization in R, what do you have to do? Right, well, first you need to figure out where is the actual code. So here's the code for this visualization. As you can see, it's just JavaScript and HTML. It has some CSS rules. It also seems to have a helper library, which is the d3.tip JavaScript library, which is also a D-tree component. And then this is the actual visualization. It's basically setting some margins. Then it's basically, for instance, creating the axis, creating the tip, the custom tooltip that we were looking at the visualization. Then it's taking the SVG element, which is just the scalar vector graphics element to create vectorized graphics inside HTML. And then it's reading the dataset. So it gets the dataset is read here, and basically creates different groups of vector graphics and adds the bar charts. Here's adding the bar chart, and also is adding the axes and the text on each axis. So this is pretty much the visualization. So what? How do we get this started in R? Well, so what you want to do is, first of all, just copy all the D-tree visualization code and then go to RStudio. And from RStudio, you can say a new D-tree file, D-tree script. And by default, this is going to give you bar chart, which it's pretty simple, but gives you some good idea of what exactly is going on and how exactly you can create a basic D-tree visualization. So one of the things to notice is that I'm going to make this a bit bigger. One of the first things to notice is that when you use R, we suggest, we recommend you use the R2D3 package. And the R2D3 package by default gives you an SVG element. Now, this is important because if you resize your visualization, you want the visualization to be responsive, and you want your visualization to allow you to basically incorporate it into Shiny applications, Flex dashboard, and why not? So it definitely needs to be resizable. By default, this particular visualization is not resizable. So if we were to change the size of this window, like the chart would be stuck on this particular size, which is not ideal. So we're gonna have to fix this visualization in order to make it usable from R. So let's just copy first all the code. We're going to leave the header on the top. This header basically tells RStudio that whenever you save the document, we want to create a preview of this particular visualization. So let's paste the code and let's just give it a shot and see what happens. So if we save it, we're hitting an error. As you can see, we're pointing you exactly to where the error is coming from, and it's telling us that d3 scale.ordinal is not available. Right. So as I mentioned, this particular file script is actually using a library, right? It's using this d3 tip library. So let's try to download this file. This should be enough, likely. We're going to call it again d3 tip .js. So we should have a library here, which we do, and it's called d3 tip. Let's just rename this. Actually, just for simplicity, what we can do is we can just copy. Let's just copy the code for now. It's going to be important actually, because we might have to do changes on this particular file. Let's just actually save it here. We're going to close this file. We don't need this anymore. And we're going to delete d3.tip.js. All right, so this one is gone. Now we have this particular file, and we're still hitting an error that the scale is not, d3 scale is not available. So let's start fixing a couple things. So one of the things to notice is that we're using d3 v3. So one of the things that we can do, we can actually we can specify the version of d3 when we are building a visualization. So we're gonna do that just to make sure that we're using the same library. And as you can see now, we have something available here, which is not looking like the rendering of the particular visualization that we need to. All right, so we're going to have to be fixing multiple things. So first thing, as I mentioned, when you're using R2D3, you actually need to, you don't need to create the SVG element. We will give you an SVG element for you. So in this case, the SVG element is already created, but as you can see here, it's getting created again. So basically, we have two SVG elements, and we don't want to do that. So one solution to do this is we can put everything, we can let the script create the SVG element, but rather than creating a top level one, we can ask it to create it inside a div. That's one option. The other option is we can just say, use the SVG that we're giving you. But now, as you can see, we have this going, right? Like we have this particular visualization there. It's rendering, but the data is not there yet, right? So we'll have to fix multiple things. Let's start by trying to fix the size. As you can see, we can't even see the axis. The other thing to notice is that in R2D3 will give you the width and the height automatically for you. This makes it resizable. So this is progress. Whenever you resize this particular visualization, now it's actually available, right? And on the correct size. All right, so we have the correct size and we have the correct element. However, the data is not correct, right? The data is being retrieved from data.tsv file, which we don't have here. So there could be two ways of doing this. One, the way that I wouldn't recommend, which is basically, like getting the data from the web. We don't want that because we want to make sure that this visualization is dynamic, and we want to make this visualization changeable from R to make it usable. So what we really want to do is basically specify this data set dynamically. So one way that we could do this would be to create a new file. And we're going to just call it data.tsv. And then we could use readr, right? So let's see, we're going to say readr, read tsv. And then we can say data.tsv, correct? All right, so we have our data set. It's the same data set. What you want to do is when you're working with R2D3 visualizations, what you want to do while you're previewing your data set is you want to specify the correct data set. So in this case, we're going to tell RStudio, whenever you render this visualization, use the this particular data set. Okay, so let's save it. Now the data is getting passed to R2D3, which is great, but we're still not using it in R2D3. The R2D3 script is still trying to read the data file from the particular data.tsv file. So this is what we're going to do. We're going to say R2D3 on render. And this is a helper function provided in R2D3 that basically gets called whenever the visualization is rendered. So we're going to get rid of this. And the parameters that it takes usually is the SVG, the width, the height, and the options. And as you can see, now that we re-render, we actually have the data. Now there's a couple issues to notice here. We already have a variable named width that we're overriding, so this is the actual width. So let's just rename this width and this height, and we also don't want to override the SVG because we already defined it and we actually transform it ourselves. So we're gonna leave this unchanged on this callback and only use the data and resave. All right, this is looking already pretty close. And again, like you can actually resize it, which is pretty great. There's still one problem here, which is that we're not making use of any styles, so the visualization still looks quite broken. Let's look back at the code, and as you can see, we still need to specify the actual CSS rules for this particular visualization. So what we want to do is we want to create a style sheet. So we're going to create a text file, and we're gonna save it, and we're gonna name it script.css. R2D3 is smart enough to find the style sheet with the same name of the script that you are rendering. So if you want this to just work like magic, you can name it script.css. If you name it something else, you would have then to tell R2D3 that what's the name of that particular style. Okay, so we've saved it, and let's just try this again. And voila, it almost looks right. Actually, mostly looks right. However, there's one particular thing here that is not the same as the previous visualization, which is the styling on the of the tooltip. So the tooltip actually has a correct style here, but is not getting applied. Now, why is that? So one of the things that we can do is we can inspect the element. And when we inspect this element, we should be able to see basically like the rules applied. But one thing to notice about R2D3 is that it uses the shadow DOM. Now, the shadow DOM is technology available in modern browsers to allow you to componentize HTML code and JavaScript and CSS styling into a self-contained context to avoid multiple visualizations to interfere with each other. So I think this is what is happening. So basically, we have our visualization, and the tooltip, which is here, is not created inside the HTML widget, which are requires in order to apply the right styles. So what do we need to do here? Well, the problem is actually on the library. It's creating an element, a top-level element. So for instance, if you were to use this particular visualization inside a Flex dashboard and you had multiple visualizations using R2D3, basically the tooltip is not going to be on the right place. So what we need to fix is we need to fix the upstream library. If we look at the code, there needs to be somewhere in here a place where we actually add the element. So for instance, in this case, it seems like this is where the node is getting created. Interesting. Okay, so we need to do two things. So the first one is we're gonna change, rather than creating an SVG element, um, we can ask R2D3 to give us a div inside of an SVG. Let's just check what is the right syntax. We're gonna ask container. We're gonna ask R2D3 to create a div instead of an SVG. But now our visualization is broken, right? Because we're appending to the SVG. Well, let's just change this to a div. And we're back in business. It's basically getting rendered inside a div inside of instead of an SVG, which is great. But we also want to fix this particular element. So we want to create. We want to add this node inside inside the div. And let's see if this helps. Yep. So so this fixes it. Rather than creating the top element in the body of the HTML object, which is not ideal. You know, what we can do now is basically ask R2D3 to give a generic div element, and then we need to fix this library to use that div and put the context there. All right, so yeah, so this is already pretty close, and the really awesome thing is that we could also render. We can take this code now with the data and the div, and we can say we do need a script here. So the data is correct, but then we're gonna pass the script, and it's called script.js, right? All right, so as you can see, we've basically created, you know, just with a single line of code, we've created these visualizations. So let's just do something a little bit more interesting. We can create an R notebook now. This works. And we can also reuse this visualization in this R notebook. Not only that, but we can potentially pass data dynamically, right? So in this case, for instance, we can just close this. In this particular case, we can just basically do everything dynamically. So we're gonna create first our data set. I'm gonna call it data set. So this should work. It's just reading a TSV file, but again, it could be completely dynamic if we wanted to. And then after this, we're just rendering the R2D3 element, which we do, and it's completely interactive, which is also pretty great. Now, one really cool thing about R2D3 and using D3 inside inside our notebooks is that you can also insert the D3 chunk directly from directly as a D3 chunk, which is just an R chunk. In this case, it's just a different type of code, which happens to be D3. So if we do something like this, we should be also able to load our data set. And after loading our data set, we should be able, well, in this case, we have the script and the data set. This in theory should work, but we might have to either specify the data set directly here, or let's see, notebook. Right, I might be missing something in order to get this to work. Oh, I think I had a typo. Did I have a typo? No, it's actually the same, which is fine. Let's see, let's try to do something. New D3 file. And we can get all these. Let's just make sure that this works properly. Okay, that's because we're using a different type of container. What are we missing here? Let's see. Let's just do the easiest D3 chunk that we can. And we have dataset, we have R2D3, which looks right. Let's just put up default dataset. And this should be working now. Oh, okay. So sorry, this dataset also requires data. So we actually need to specify this particular dataset here. All right. So this one is working. Let's just do something else. Let's just copy this particular dataset and just give it another try. And the data. Oh, okay. I'm missing the script as well. Sorry. Yeah. I'm missing the script. Yeah, we need the script. And the interesting thing about here is that if we wanted to do it this way, which it's not great, I think we would have to basically put the whole script here. So I'll file a GitHub issue to add support for the script, because there's good cases on just being able to basically do this without having to having to paste the whole script, which would be quite annoying. But instead, what we can do is, as I was mentioning, is if you have a big script like this one, what I would recommend you do is just simply you can just use the R code, and just use it as R code, which is quite straightforward and also pretty easy to get working. All right, so hopefully this gave you a good idea of when you want to integrate D3 elements or D3 visualizations into R. Hopefully this gave you like a good sense of what to look for, how to transform the renderings from the D3 script into the R2D3 script, which happens to be pretty close, but it needs to be usually edited, because in order to have a high quality visualization useful in R, you need to handle resizing and also being able to support multiple D3 scripts within the same particular visualization. So it does involve a little bit more work as we went through this video, but it's usually not terrible. One feature I should have mentioned, which I'll mention before we finish this video. If you hit issues, right? So how do you debug this particular problem? So suppose that you misspell something here. Let's see if this works. Oh, it's still working. Why is this working? Oh, because you're using the data here. Okay, let's just fake a mistake here. Here, for instance, in this case, data 2 is not defined. Okay, in this case, as you can see, you're getting point to the right element. But suppose that we have something a little bit worse. Suppose that we have something like this. Yeah. So in this case, I introduce a problem that we know how to solve, but like suppose that we don't. So how do you go about this? Well, one of the ways that you can actually help you troubleshoot particular problems is in JavaScript. You can use what is called the console.logging, which basically allows you to print anything to the console. When you're using R2D3, what we do instead is R2D3 prints into the visualization the message. So in this case, as you can see here, hello world is getting printed. So one of the ways of troubleshooting visualizations is, if you're not sure what is the value of letter, you can use print statements and say, we can do something like the value, right? And we could potentially print it and say, okay, like, what is the value of the letter? Okay, this particular element has letter C, and maybe this is relevant or not. And it can be quite tricky, honestly, to troubleshoot visualizations if they're not rendering properly. You'll probably have to spend time understanding what the visualization is doing and how to change it. But eventually, you can use these tools like the console, or also, inspecting the elements to try to figure out what is going wrong on the particular D3 visualization. So again, thank you. Thanks a lot for watching this video. Hope it was useful, and we'll keep in touch.